But that's going to be a point. I forgot to remind you, so here's your nice friendly reminder. I have not typed in the 0 for the steady eye, but it is coming. So why didn't you turn in your steady eye? It was, you only had to do evens. There are 28 problems. I made it out of 14 points. It's 14 points in the 30% category, which is really not that much in the grand scheme of things. But at the same time, we have so few grades in, it is going to impact your average if you do not turn it in. So just a reminder, did you turn in your study guide? Okay. So you would like to have most of class time, because most of us did not get near far enough along on our tests. You would like to have, yes, you can. Go for it. If you're going to forget about it, turn it in now, that's fine. You would like to have most of the class period to finish your test, because most of us need a little extra time, which I totally understand. So we have to get through little notes first, and then we can. We are super behind on something. Does anyone know what that something is?
Workshops. Notes.
Whoa. It's like we're the same person today. Alana, can I have another point? We're super behind on workshops. If you look at the top of the workshop page we're currently working, it's 10.2 to 10.6, and we are now at 10.17. So we are super behind. We've got to get caught back up. So today we're going to do 8, 9, and 10. Tomorrow we're going to do a lot of workshop problems. And for the rest of the week, until we can get caught back up to the rest of our trig, we're going to have to double up on workshops. So you picked up your new page on the way in. Go ahead and circle, let's see, we're going to do 9 through 13 tomorrow. So if you're trying to get a head start on your life, and you're wanting your group to get a lot of points, circle 9 through 13 and have those done tomorrow. I am actually not going to be here tomorrow, but so I can actually see who did get those. Oh, I'm throwing her on the bus as she walks in. I'll ask Miss Brister if she'll walk around, and if you'll show Miss Brister that you did 9 through 13 in advance, I will make sure your group gets a point when I get back.
Miss Brister,
we're behind on math workshop, but 9 through 13, if they have it done and show you tomorrow, and I mean everybody in the whole group has to have it done. But if everyone in the whole group has it done before I go over it in the video, they can have an extra point or 2. Let's say 2. 2. Okay, so we're behind on math workshops. We've got to get caught back up. And we are a little behind in notes, but it's really no big deal because matrices are pretty much my favorite thing ever, and they're going to be yours too. So, let's see. We skipped number 8 a couple weeks ago. Does anyone know the first thing we should do on number 8?
Yes. We should add, combine,
1 and 2 get a point. So it would be x squared plus 6x plus 8. Now I need to factor this, and I'm out of room. Can someone go ahead and tell me the 2 factors? I need something to add to give me 6 and multiply to give me 8.
Okay, 46, 30.
Who said it? Was it you? I thought it was you, Hunter. You can have a point. It is 4 and 2, so x plus 2, x plus 4. Very good. Okay, our next math workshop that we skipped is number 9. And I'm looking at it, and I can already tell there's a GCF. What's the GCF I need to pull out of number 9? It is PQ, but what else? It's not 9. Yes, it's 3 PQ. Your group can have a point. So we factor out a 3 PQ. We're left with a P squared minus 3Q. Dave's group gets a point. Okay, and last but not least, I see number 10, and it has 4 terms. So what method do we use when there are 4 terms? Yes, dear?
Parentheses, 2 up.
Yes, that is correct, and you can have a point for that, Arturo. What do we technically call that when we put 2 in parentheses and 2 others in parentheses? We had a term for that. Starts with a G. Paige got it. It's grouping. We call this grouping. When there are 4 terms, we try grouping. Now, our first thought is there a GCF that goes into everything? And there's not. But that is always my first thought. Is there a GCF? There's not on this one. So I have to put them in parentheses, each set, each pair of terms. And then I've got to ask myself, what's the GCF of this first thing? So 10x squared minus 14x, what can I pull out?
2x.
Get a point there. 2x, you would be left with 5x.
Minus 7y.
2 and 3 get a point. And then on the next one, I should pull out what?
3, negative 3.
And then what would you be left with?
5x minus 7y.
And I'm very happy that you said that, even though I can't write 5x minus 7y. I'm very happy that you said that because unlike me, you can write correctly and the two inside things match. So my final answer is,
2x minus 3 times 5x minus 7y.
and you can get another point. Mia's starting to question her own sanity at this point. How can she check herself? What is the acronym called if she wants to check herself and see if it matches the original?
Plug it back in.
Foil method.
Our sheriff is another point. We can FOIL it out and see if we get back to the original. Now, technically, it is distributing. I get that. But when we do that first, outer, inner, last, we've always called that FOIL. That's our acronym. Okay, I hope there are no questions about that. Again, if you're trying to get ahead on tomorrow, if you'll show Ms. Brister, your entire group has to have it done to get 2 extra bonus points. Or 2 extra points for your participation. But if Ms. Brister, if the whole group shows her you have 9 through 13 done tomorrow on the one you picked up on the way in, then I will give your group 2 extra points. So if your group's super good and the sub brags on your group, let's say that Seth is so helpful. She writes a note about how helpful Seth was. So I'm already going to feel sorry for this group in the 6. And then if they already had this done, they go up to an 8. No one ever said you had to stop at 5 every day. I mean, the goal is to get to 5 every day, and if you're not, you got a problem. But no one ever said you had to stop at 5. Okay. You would like for me to talk a little faster so you could have a little more time on your test. So let's go to your new notes packet. We're going to talk about something called matrices. For our next test, it's going to be completely on matrices. Okay, today we're going to do the top 2 learning targets. We're going to learn how to state the dimensions of a matrix. And we're going to solve equations involving matrices.
You got some tape?
Yeah, in that top left drawer. Okay, so, does anyone know what a matrix is? Has anyone seen a matrix besides maybe the Matrix? Maybe you have, maybe you haven't. Okay, go to the first page. It shows you an example. Okay, so a matrix is really just this. It's normally in brackets like this. Sometimes people get lazy and they don't put the brackets. And sometimes people get weird and they use parentheses instead of brackets. But anytime you see a bunch of numbers lined up like this, it's probably representing a matrix. The top blank is matrix. A matrix is a rectangular array of variables or constants, and they're in rows and columns, and they're usually enclosed in brackets. And you're like, okay, that's great. Why do we have matrices? And so the reason we have matrices is if we have a lot of data, a lot of stuff we want to store, the easiest way to store it is with a matrix. Okay, raise your hand if you just super duper duper loved 3 equations, 3 unknowns.
Heck no.
Raise your hand if you super duper duper love the challenge problems, the 4 or 5 equations with 4 or 5 unknowns. Do you see how no one's raising their hands? Then you're going to say thank you God for matrices, because matrices are about to make our life so much easier, because you're going to be super mad to find out your handy dandy little calculator can do all the things we've been doing. There's certain buttons we're going to press and it's going to solve all the things, and your pretty little brain won't actually have to solve a 3x3 or 3 equations, 3 unknowns anymore. That's the cool part. Okay, in real life, does anyone like Netflix? I'm a Netflix junkie. So I finished this show. I don't know if I want to tell you about my viewing habits. I finished Unbreakable Kimmy Schmidt. I don't know if you've seen it. It's dumb. It was dumb like The Office was dumb. I like those kind of like stupid shows that have like current sense of humor. Anyway, so Netflix, once you finish a show, 4 out of point because you're so quiet. When you finish a show, you know how, and 6 out of point. You know how it recommends a new show for you? And it says like a 98% match or 80% match, and you're like, Netflix, how do you know all this stuff about me? Because I started a new show, and I was like, how did you know I was going to like this, Netflix? I don't understand. Netflix is actually using matrices to figure out what your likes would be based on what you've watched before. They use matrices. Now, theirs are going to be a little more complicated than what you and I are going to tackle today. But, so a cool thing in real life that uses matrices is Netflix, because I freaking love Netflix. I love when it recommends things. It seems to just know what I like. Yes, dear. It was. It was funny. Okay, so first things first. Does anyone know what a row is and what a column is?
Yes.
Okay. Well, 261 would be a row or a column. That's a row. A column looks like it's holding a building up. It's got to be straight up and down. So like 27912 or 27912, that would be a column. Now, it is important with matrices to know which one's a row, which one's a column. I'm sorry to lose a point. Oh. And not only do you have to know the rows and the columns, like this one has how many rows and how many columns. And you can have a point, Hunter. Okay, so it's not only important to know that it's got 4 rows and 3 columns, or 4 columns and 3 rows. Sorry, I said that wrong. You also have to know stuff like, what number entry is this? So we'll talk about that in just a second. Oh. Okay, let's go first things first. If we're wanting to say like a certain size, because this matrix was 4 columns, 3 rows, that clearly, or yeah, 3 columns, 4 rows, it's clearly a certain size, and we're wanting to state the size of a matrix, we call that its dimensions. So in the next part, it says state the dimensions. Really what they're wanting to know is the size. How big is it? How many rows? How many columns? And what really stinks, and I get confused on it all the time, and you will too, is you have to be particular about the order. It's M rows and N columns. So it needs to be rows by columns. And it's really tempting to do columns by rows sometimes. I'm with you. You have to do rows by columns. Yes. So we'll say, for instance, in our example, we had 4 rows and 3 columns. So we had a 4 by 3 matrix. Okay, and then it even said that down below. Matrix A above is a 4 by 3. And that's another thing I should tell you, is that matrices, you know how if you see a variable and it's lowercase, you know you're supposed to solve for it? A matrix is always represented with an uppercase letter, like a capital A, a capital B. And it's just going to come up later on. It's not really that drastic. It's just something that happens. And you're like, why does it get to be cool and be the capital letters? Everyone else has been lowercase. That's not fair. But it's that way we know it has a lot of data. Yes, dear? It's technically, well, it's got 3 rows and 1 column, so 3 by 1. This is 11. Okay, so I did number 11. It's got 3 rows, 1, 2, 3 rows, and it's the 1 column, so it's a 3 by 1. Okay, can someone else help me with, let's say, number 10?
2 by 3.
It's got 2 rows and 3 columns, so it's a 2 by 3. So that's group, get a point. Number 12 is a
3 by 4.
4 by 3.
Is it 4 by 3 or 3 by 4?
4 by 3.
It's 4 rows, 3 columns, so it's 4 by 3. I'm telling you, Arturo, it gets me every time. 1, 2, well, not 2 because 2 is on there. Sorry, 2. 1 and 6 at a point. Okay, and then 13
3 by 3.
is a 3 by 3. You can get your point. And then 14 is
2.
2 by 5. I said it first. I was one of my team.
I actually did hear you first, so you can have it. They didn't hear you, though. And then the last one is a 3 by 2. Natalie, you were the most passionate. You can have it. Okay, so, and then I just got so much to tell you about matrices. It's all going to come out now. Our favorite kind are when they have the same numbers. Like a 3 by 3, we're going to call that a square matrix because it's the same number each time. And you don't actually have to know that vocab term. Just know that if you're going to go ahead and know which one's your favorite, it's the ones that have the same number of rows and same number of columns. They're always the easiest. I love it when they have the same number of rows, same number of columns. Okay, so you can already tackle the top learning target. You can state the dimensions of a matrix. Good for you. That's the easy part. One thing that we do need to talk about is you have to be able to identify each individual element. So, for instance, back to 261, that top example, our giant matrix A. Entry 2, that first spot that it's holding, it is in the first row, the first column, right? So it's technically in the 1, 1 spot. So if they ask you what's in the 1, 1 position, they're talking about the number 2 is holding in that spot. Now, that's not something we're going to ask in Algebra 2 Treg for the most part, but I have seen ACT questions like this. Well, they'll give you a matrix and they'll say what's in the 2, 3 position, and so you have to know second row, third column, so it's the 5. And really, the reason they ask that is that proves that you can actually read a matrix because you understand it's rows by columns. That's a better way. They're probably going to ask you to do this rather than state the dimensions because everybody can state the dimensions. It's either going to be a, like me and Arturo are arguing about, it's either a 3 by 4 or a 4 by 3. Like, and both answers are going to be on there. So this is a better question to ask you specifically, like, what is the 2, 3 entry? Just FYI. Okay, so I love me some matrices. If we want to solve an equation with a matrix, what's really cool is if there's an equal sign. So go down to 16. If there's an equal sign, then it literally is telling you this first entry is supposed to match this first entry. This second entry is supposed to match this second entry. And then that third entry is supposed to match that third entry. So literally it's like who you think is supposed to match do match. So for instance in ours, if we solved it, number 16, we would have 2x equals 5. So x equals 5 over 2. Then for that middle thing, we would have 3 equals 3y. So we divide by 3. We'll get y equals 1. And then for that third entry, we would have 3z equals 9. We divide by 3. We end up getting z equals 3. So we've already solved for an x, y, and a z, and it literally took us seconds. Okay, well, I did that one. On number 17, what is x?
4x.
Dave, you can get the point. You were super close, Seth. You almost had it. Okay, so on number 17, we would do 4x equals 12, so x equals 3. What does y equal?
1, no, -3.
What does y equal? Go ahead and tell me.
3y is equal to -1.
So what does y equal?
Y equals -1.
That is correct. And if you already know the answer, I'm really not going to be mad at you in this section if you just go straight to the answer. Okay, are there any questions on 17? That's the answer. So literally, Paige has a good question. If you want to plug it back in and check yourself, you can. So if you were to plug back in the 3, you would have 4 times 3. And then 3 times y was -1/3. And if we actually do those operations, well, 4 times 3 is 12. 3 times -1/3 is -1. Hey, lo and behold, we got what was on the right anyway. So literally, we're picking values to force it to be true. We're making 4x equal to 12 by picking x to equal 3. Okay, let's go to number 18. It's a little more complicated. Does anyone already know the value of x?
I don't got you.
4.
So would it be 4x
Equals what? Plus what?
X.
It literally is the top entries equal to each other. So 4x equal to 15 plus x. I realize both pieces had a variable this time. I realize that. But again, they were both on the top of that matrix, so they're supposed to be equal because it has the equal sign. So I literally set 4x equal to 15x. I end up getting x equals what number?
5.
You can have a point there. So you subtract x, you get 3x equals 15, so x ends up equaling 5. Okay, someone's already solved for y. What did y end up being? Will's group get a point. They need a point. You already got like 7. You can have your 5th. Yeah, he's been talking. He's finally clocked in. You know, let's since he's gonna do math today, we gotta give him a point. Will knows I love him. We have a understanding that I love him. Okay, 19 looks a little harder. Why does 19 look harder? It does have more variables, and it also has a more complicated matrix. I'm supposed to set 4x minus 3 equal to what?
9 minus 15, negative.
Which one?
9.
I literally set 4x minus 3 equal to 9. They're both in that 1, 1 spot. I'm going to set them equal to each other. 4x minus 3 equals 9. So x ends up equaling...
3.
You have a point. Double 6. It's 4x equals 12, so x equals 3. Okay, what does y end up equaling?
3y.
Don't tell everybody, just tell me the answer.
Oh, my.
What does y end up equaling?
Y.
It's negative 5. It's negative 5. People,
I got it.
I did 3y equal to negative 15 because they were both in that second spot on the top. And so I said 3y equals negative 15, so I got y equals negative 5. I do need to solve for z. Why do I not have to do anything on the bottom left? Yeah, it's already 7 equals 7. We don't have to do anything. That was very good. Every group can have a point. And then for the other one, I have 13 equals blah, blah, blah. What does z end up equaling? What does z end up equaling? It's not 7.
Z equals 6.
Z equals 6. I sure get a point. We do 13 equal to 2z plus 1, so 12 equals 2z, so z equals 6. So you're already understanding why I love matrices. Because they just make life so much easier. Again, all they're used for is to store stuff. But man, when they store stuff and we start doing problems with them, life just, it's like birds and the bees come out, and life just gets happy. I'm just super happy about it. Super happy about it. The only thing that is slightly annoying with matrices is multiplying them, but we're going to deal with that bad boy when we get there. And it's only annoying if you let it be annoying. Otherwise, it's just as happy. Okay, if you look at the next page, I'm going to be super nice because people need to finish their test, and I'm going to save all my words for the next page till tomorrow. But basically, operations with matrix, birds and bees, everything you want to happen happens. You think adding, you think I'll add the top 2 together, I'll add the middle 2 together. That's exactly what happens. You get to add the entries together that you think go together. When you subtract, for instance on number 5, I do 5 minus a negative 8. But I will go through all this tomorrow with my video that I'll leave for you. So what stinks for you is tomorrow you're going to have to get through these notes. And you're going to have to work on flip page, this worksheet. So it would be wise of you, if you're already done with your test, it would be wise of you to get a head start on this worksheet. Because for sure, Seth can do the top 6 like this, because he knows how to state the dimensions really quickly. And then 7 through 20, he can still do those super fast. There is one that is annoying. Does anyone see the really annoying problem? 16 is not the really annoying problem.
18.
There's no 21. 12. No.
Isn't that 18? All of them?
No. 20 is the really annoying. Does anyone know why 20 is the most annoying?
Because there's an egg.
Yeah, so I'm going to say that if you want to skip 20 and wait for me to return for that one, I'm going to understand. So you can skip 20. If you try, you end up getting a point. My suggestion would be to use substitution. But I know how much you love it when I say those words, so it's going to be okay if you skip 20. So again, I'm just making a suggestion. I'm about to give you all the rest of the class to finish your test if you need to, or those of us who need to finish that study guide and turn it in could too. But tomorrow I'm not going to be here. You're going to have a little bit of notes on matrices, the bell ringers, math workshops we just talked about, and I'm expecting Seth to finish this whole page. When I come back on Thursday,